Hello dear student. Now today we will discuss about the properties of that modern periodic table. Now see that there are 5 types of properties which are included in your syllabus. That is first one, it is that ionization enthalpy. Second one is that ionization gain enthalpy or electron gain enthalpy. Third one is that it's a electronegativity. Fourth one is a valency. And fifth one is it's a atomic radius or atomic size is there. Sixth one is also there. This is a metallic and non-metallic characters which are present in that periodic table. We already said this all parts in that the pictorial form in your groups are there. So see properly. But see that before we study these properties, we can get that these 3 factors are much important. That first one, that is called as an atomic size is there. Now see that this atomic size or that atomic radius, it belongs to that the distance between that the nucleus and outermost shell of these electrons. So see that suppose this is a nucleus in which that neutron and proton can be used into it. Then there are various types of shells are there, correct? And in these shells that electrons can revolve around it. So the distance from that nucleus to that outermost shell, this is called as its atomic size will be there, or it is called as it's a atomic radius also is there. This is the first factor that will be important. If you see in the modern periodic table, according to this atomic size, suppose we can considering this is a vertical part, this is called as a group, while this is a horizontal part, this is called as it's a period. So see that from that it's a top to bottom. In this case, this is a group. In this top to bottom, that atomic number should be increases. Just like for first group is there. So this is hydrogen, then lithium, then sodium, then potassium, then rubidium, then cesium, and then francium. So see that this first group will be there. So its atomic number is 1, then its atomic number is 3, its atomic number is 11, its atomic number is 19. So say that this atomic number should be increases by shell to shell will be there. So naturally its atomic size is also increases into it. So it will be happen from top to bottom that atomic size is increases with increasing their atomic number is there. While on the contrary, along this period will be there. Suppose this is a lithium, then beryllium is a 4, then boron is a 5, then carbon is a 6, nitrogen is a 7, then oxygen is a 8, then fluorine is a 9, and this neon is a 10. Then what happens here? So that left to right along this period, it is observed that the electron can be increases by only 1 will be there. And here, the number of shells should be changes in it. So then what happens here? So from left to right, as the atomic number is increases by 1 by 1, then it will be obtained that its a atomic size somewhat to be that decrease from left to right will be there. Why it is so? Because this second factor, it belongs to that nuclear charge. And nuclear charge is nothing but the forces of attraction that lie between that this outermost electron and the nucleus will be there. So in general, according to this nuclear charge, it is observed that as a smaller atomic size, then nuclear charge will be to be that it should be increases, while in the higher atomic size, that nuclear charge will be decreases. So in general, we can observe that from top to bottom, that nuclear charge is decreases, while from left to right, that nuclear charge is to be increases. So it will be depends upon that. Then second, this is first factor, this is second factor. Third factor is also that it is called as a shielding type of that effect. Now what is the idea of this shielding effect? So shielding effect is like that. So that the atom can having that different types of that. It's a orbitals are there, shells are there. And suppose that inner shells are incompletely filled, while that outer shells are completely filled, then such effect is called as that shielding effect. So what happens here? That inner shells are to be that incompletely filled, so there is a instability which is to be arises in case of that. And if that poor shielding effect is arises, then say that it will be directly affected on that the different types of that properties of belongs to that the elements are there. So in case of that atomic size and atomic radius, that it will be getting that from top to bottom atomic size increases, while that it is from left to right along that period atomic size decreases from left to right will be there. Now this is the first factor. Now see that the second property, it is belongs to that the electronegativity. Now electronegativity is what? So electronegativity is that the power or ability of an atom, of an element to pulls the electron toward itself. It is called as that electronegativity. So in general, that pulling of this electron, it is simply called as that electronegativity. Now this electronegativity, it will be depends upon its atomic size and nuclear charge. In general, it is observed that as the atomic size is to be increases, then say that electronegativity decreases. While in case of that atomic size is to be decreases, then it will be getting that, it will be that the electronegativity should be increases. Means in general, small atomic size having that larger type of that electronegativity, while that larger atomic size has smaller type of that electronegativity. So in modern periodic table, fluorine is a such element which having that the highest electronegativity among that all groups are there. Again, according to electronegativity, this halogen family, that is group number 17, which having that the highest electronegativity power will be there. So in general, we can get a top to bottom electronegativity is decreases, while left to right electronegativity will be increases. This is the idea of that electronegativity. Now third factor, it is called as that, it's a ionization enthalpy. Now so that it is also called as that ionization potential is also there, or it is also called as that IP value is there. Now so that definition of this IP is like that, the amount of energy which is required to remove that this outermost electron from its shell, it is called as that, it is ionization enthalpy. Means in general, the power or that energy which is to be consumed, that removal of this electron in this gaseous state, it is simply called as that ionization enthalpy. Again, it will be depends upon these two factors, that atomic size and nuclear charge. So from top to bottom, atomic size is to be increases. So naturally, ionization enthalpy value is to be that decreases, because that as the atomic size is more, then say the value of ionization enthalpy is to be that it's a less. While from left to right, that atomic size is to be decreases, so naturally the value of this ionization enthalpy is to be increases. Actually, there are three types of ionization enthalpy. So that first electron which is removed and then amount of energy which is required, this is a first ionization enthalpy. Again similarly, that second electron is removed, then it is second ionization enthalpy. And maximum, that third electron is removed from that any atoms, then it is a third ionization enthalpy. So the energy which is required for that first to that second, so that second ionization potential value or enthalpy value, it is much higher than that of the second, and then third, it required that maximum energy. So that's why third ionization potential is always more in case of that. So this is the first, this is the second property, it is belongs to it. Then see that this third property, it is a electron gain enthalpy will be there. So in case of this electron gain enthalpy, then what happens here? So electron gain enthalpy means the amount of energy which is required to add the electron from that any atom to that its outermost orbital will be there. Means in this case, amount of energy which is required to adding the electron into it. Again, it will be depends upon that the size. So it will be getting that from that group will be there. So top to bottom, again this atomic size is increases. So the addition of this electron is easier one. While from left to right, that atomic size is to be decreased, so that's why it is a tough to that the adding of this electron to its outermost shell will be there. So this is the idea behind this electron gain enthalpy is there. Now fourth property, that metallic and non-metallic character will be there. So if you observe that the periodic table, group number first is alkali metals, group number second it is alkaline earth metal. Now total D block element containing that all metals are to be there. And say that this non-metal should be started in the P block element. Hydrogen is still also that gases, it is counted as a non-metal in that S block element. While that metals, non-metals and metalloids which are to be increases, which are to be present in that the P block elements will be there. So P block contain metal, non-metal, metalloid, all types of this character. But according to the string, it is observed that metal is that the element which is lost the electron, while non-metal is the element which is to be that it will gain the electron, while the metalloid are there, so it will be may accept or may gain as per that situation of that condition of that particular atom should be there. So in general, from top to bottom in a group, that metallic character is increases, Means that generally that if you observe that the groups are started from that non-metal and end with that the metal. So from top to bottom that metallic character is increases, while in case of that left to right that non-metallic character is to be increases. In the at the last that group number 18, it is called as that simply noble gas elements, which are mostly all the gases are there. So the end of that period, which is to be that with the gaseous part. So that's why that non-metallic character is increases from left to right. Then for next properties belongs to that oxidation state will be there. So oxidation state, it is that the numerical or algebraic charge which is to be carried by an atom or by an element to its it is called as that oxidation state will be there. Oxidation state and valency which are belongs to each other. In case of that valency, there is no charge. It is only the number of that atoms of that electrons may be gained or may be lost. While in case of oxidation state, it carries a numerical charge in it. So if the positive charge arises, then say that the element definitely it loses the electron. While that negative charge will be there, so it will be that definitely it is a gain the electron. While that zero will be there, so it is not gain, not loss of this electrons are to be there. Then it will be observed that is group number first. It's a valency is +1. Then say that it's a oxidation state is like that. It is +1, then +2, then +3, then +4. And then afterward, this is -3, then -2, then -1, and afterward, that is lastly, it's a oxidation state is 0. Means it is observed that first oxidation state is increases and then suddenly decreases, and lastly it becomes at the 0. This is the idea of this oxidation state starting there. So these are the properties which are included into it. Yesterday I have already added that so many images belongs to that these properties are there. So properly see, and if any difficulties are there, then you may ask me. Have a good day. Thanks.